So, good morning, my dear students. My name is Bishoy Salama. I am your teacher for teaching chemistry O level. This lesson will be concerning the Cambridge syllabus, and we will start explaining our first lesson, which is named States of Matter. Okay, to take a brief account about our syllabus, let's go to see our index. So, this is the topics are found in our syllabus. The first one is named Particulate Nature of Matter, or we can name it States of Matter. And number two, it's experimental techniques. And this topic is dealing and concerning with the separation techniques used to separate different components of a mixture. And topic number three, I think you have been familiar with this topic during the past years, which is concerning the atomic structure, elements, and compounds. What is the atom made of? It's made from protons, neutrons, and electrons, and electronic configuration. And how do elements react with each other? And how do the atoms combine with each other via ionic bonding, covalent bonding, and also metallic bonding? Topic number four, it's named stoichiometry. I don't think you have taken such related topic in your past years in school, but this topic is almost related somehow with chemical calculations. It's like a mathematical topic. So let's go to topic number five, and it's related with the periodic table. And I think you have seen many topics and many issues about the periodic table in the past years. And then topic number six, which is named electrolysis. And I think that you will hear from your friends that it's almost a hard topic and it's not that easy one. But I promise you that when you see my videos, you will find this topic is almost an easy one. Then we can go to topic number seven, and it's concerning acid, bases, and salts. Yes, you took acids, you took bases, you took something named pH in your past years, especially in your pre-IG grade 9. And for topic number eight, it's concerning metals and reactivity theories. It's talking about metals and how do metals react. Topic number nine is related and concerning energetics of reaction. And as you know, that any chemical reaction is involving a change in energy. Either it produce energy or take in energy. Topic number nine is concerning the rates of reaction and how is the reaction fast or slow and what do affect the rates of reaction. What are the factors that affect the rate of reaction? Topic number 11, it's an easy one concerning air and water, and you have been familiar with these points all over your past years in school. Topic number 12 is also an easy one concerning a non-metal like sulfur. It's an important non-metal. And topic number 13 is dealing with carbonates, and then our large topic, which is organic chemistry. You will also hear that this topic is a hard one. It's a large one. It's a tall topic, but almost you will find that this topic is the easiest topic among your syllabus. Yes, it's a large topic, not a small topic, but it's very easy and it's very interesting. So let's start our topic number one, which is concerning the particulate nature of matter. Um, while I'll make you videos for all the chemistry topics, and I'll try not to have a video length more than 45 minutes. I'll always try to have the videos less than 45 minutes. Okay, again, here are the topics we talked about at the beginning of my video. Topic one, as I told you, states of matter. Topic two, experimental techniques. Topic three, atoms and elements. Topic four, named stoichiometry. And we talked about this topic that it's concerning mathematical calculations. Topic number 5, which is the periodic table. Topic number 6, which is electrolysis. Topic number 7, which is acid, base, and salts. 8, metals and reactivity series. Topic number 9, which is energetics of reaction. Topic number 10, chemical reactions. 11, air and water, sulfur, carbonates, and finally we will end with organic chemistry. So this is topic number 1. And topic number 1 is dealing with the particulate nature of matter. Okay, let's ask you a question. I know that no one will answer me, but I like to interact very much during my lessons. But I know that no one will answer, but I will answer myself as I'm a student. So the first one is the particulate nature of matter. So what is meant by matter? What is the meaning of matter? Yes, we took in the past years that matter is anything that have a mass and volume. What is meant by mass and what is meant by volume? Mass, like the amount of matter that the substance contains. Any substance is consisting of small particles. These particles are giving this substance its mass. And then we can ask about what is meant by volume. Volume means the space occupied by a certain object, a certain substance, or any. So everything that has a mass and volume is called matter. Everything that has two properties, which are mass and volume. Any object that has a mass and volume is called matter. So, am I considered a matter? Yes, I'm considered a matter. You are considered a matter? Yes. Any objects, if it is living or non-living, but it has a mass and a certain volume, it occupies a volume in space, is considered a matter. Yes, you know that matter is made up of very tiny particles, small particles. Yes, these particles are named atoms, are named molecules, and even they are called some type of ions. Maybe atoms, molecules, or even ions. We will take in topic 3 the difference between atoms, molecule, and ions. But let's know that any substance, any object around you is consisting of tiny particles. These particles may be atoms, molecules, or even ions. We can know and explain this theory by the following. First of all, we need to know what are the different states of matter. Yes, matter can be found in different three states. Do you know these states? Yes, someone will tell me that these states are solid, liquid, and gases. Is there any other states you can find? No, there are no other states, but I will wait for the comment section. The fourth state of matter, it's a newly one. It's not solid, liquid, and gas, it's something out of the syllabus. If someone needs to, we can discuss anything, even if it is out the syllabus. Okay. So for our syllabus, they are solid, liquid, and gas. Let's open a new whiteboard and try to talk about solid, liquid, and gas. Yes, here they are, solid, liquid, and gases. Let's talk about different points of comparison. Points of comparison. Points of comparison, POC. Okay, let's start with the shape. Yes. Do the solid objects have a fixed shape or unfixed shape? Your cell phone is having a fixed shape, or does it take the shape of the container? When you put your cell phone in a large bowl, Does it take the shape of this ball? No, it does not change its shape. So it is having a fixed shape. And we will know why do solid have fixed shape. So let's go to the liquids. Do liquids have a fixed shape or unfixed shape? Yes, the liquid takes the shape of the container. When you move the liquid substance from a container to another container, like from a bowl to a tall cup or any, yes, it will take the shape of this container. That means that the liquid changes its shape. So it is having unfixed shape. So let's go for the gas. Yes, the gas in a balloon, for instance. Does the gas take the shape of the container or the gas cannot take the shape of the container? No, the gas can take the shape of the container. Yes, the gas can take the shape of the container. If you move the gas from a balloon, a tall balloon, into a ball-like ball balloon, the gas will take the shape of the container. So also the gas is having unfixed shape. Yes, this is we can deduce from the states of matter around us. Let's go to the volume. Does the solid have a fixed shape, fixed volume or not? Yes, the solid does not change its shape. So it will not change the space occupied in space. It will not change the space occupied. So it will also have a fixed volume. Yes, the solid is having a fixed volume. It almost does not change its shape. Something that cannot change its shape is for a must. It does not change its volume because even no particles can move from their places into another place. So the volume will be kept constant. But let's go for the liquid. Can I have different shapes with the same volume? Is that possible? Yes, that is possible in some cases. Like if I having a cube like this, and this cube is having a length of 5 centimeter and is having a height of 5 centimeter and is having a width of 10 centimeter. What will be the total volume? Total volume is 5 times 5 times 10. So it is equal 5 times 5, 25, 25 times 10, it's 250 centimeter cube. Can I have a different shape with the same volume? Yes, if I'm having this cuboid. Imagine, for instance, that the length, for instance, that the length is kept 5 centimeter, but the height was 10 centimeter and width became 5 centimeter. Forgive me for that drawing, but I'm using an electronic pen. But let's try to find the volume for this cuboid. Yes, it will be equal volume equal 5 times 10 times 5. So it will equal at the end 250 centimeter cube. Yes, they are having the same volume, but different shapes. Okay, let's go back. That means that for unfixed shape, it might have the same volume. For unfixed shapes, they might have the same volume and they might not. But in the liquid case, let's know for now that they are having also fixed volume. Look, everything in chemistry is having a why. We can ask why for anything. Nothing is being memorized or studied as it is. Everything is having a reason. So, why do solids have a fixed shape? Why do they have fixed volumes? Why do have unfixed shape, liquids, and fixed volume? Why do gases having unfixed shape? And now, what about the volume of the gas? Yes, it is also unfixed. volume. We will know now why do gases having unfixed shape, they can change their shapes and they can also change their volumes. Do you know if you have a glass full of a liquid till this part and you try it to compress this liquid to take a, a, a smaller length for this glass, it will not be possible. You cannot, impossible. This is very hard to compress a liquid, but it is possible to compress a gas. If you are having a gas in a balloon, yes, you can press the balloon, and at some point it will get ruptured and it will explode. But this can give us an indication that liquids are having fixed volume. They cannot be compressed. You cannot decrease this volume. You cannot apply a compression here and you can compress it and you can find the length or the reading change it from here to here, for instance. No, this is not possible. But for a gas, yes, it's possible. If you put a gas in a glass cup and you try to compress it with a piston, yes, you can get it from this reading to this reading or from this graduation to that surface. Yes, it is possible. So let's know now that liquids are having fixed volume, but gases are having unfixed volume. Okay, let's talk about an important point of comparison, which is energy. Yes, we said at the beginning of the lesson that every matter is consisting of tiny particles. Solid is consisting of tiny particles, liquids are consisting of tiny particles, also gases are consisting of tiny particles. But let's know that solids are having low amount of energy. Particles are not energetic. Yes, the particles cannot change their shape. The solid cannot change its shape. That means that the particles are having low amount of energy and it also cannot change its volume. That means that there is almost no distance between particles. Particles are very close. You cannot change or decrease the volume. So let's predict what about the energy with the liquid particles. Yes, the energy with the liquid particles is moderate amount of energy. Why it is moderate? Because they are having unfixed shape, so the particles can change their shapes. If you are with your friends and you are holding your hands and you are making a circle, you can make another shape to make a cube. You can make another shape to make a cuboid, sorry, a square, or you can make a rectangle, or you can make a circle. Yes, you can do that. You can change your shapes. But when can you change the shape? If you are energetic, if you are having some energy, you can move from your place. Like, for instance, in the Olympic playings and in the introduction for an Olympic match, I can see that some people comes inside uh, the playground and make some shapes. They can make circles, they can make stars with their um, own selves. Yes, they can move around to make many shapes. You can see these shapes from a helicopter, for instance. Yes, they can change their shapes because they are having some energy. But imagine that those people do not have any energy or almost very low amount of energy. They cannot move from their places and consequently they cannot change their shapes. Let's go for the gas. Yes, gases are very energetic because they can change their shapes and also they can change their volume. Gases are having high amount of energy. Let's go to another point of comparison, which is force, or we make another name, attraction force between particles. So, attraction forces between particles. Try to think with me. Particles are having low amount of energy. They are having fixed shape. Do you think the attraction forces between the particles is large or low attraction force? High attraction force or small attraction force? Strong attraction force or weak attraction force? Yes, I can hear someone that can tell me that it is strong attraction forces. Yes, it is strong attraction forces. They are having low energy. They cannot move. So the force will be huge, holding them together. They cannot move. They are having low energy. So the force will win this war. The force will win this fight. The force is always the opposite of energy. The force will win this fight. And the particles cannot move from their places. And liquids are having, yes, medium attraction forces, and for sure gases are having low attraction forces or weak attraction forces between particles. Why? Because the gases are have particles are having high energy, so they can overcome this attraction force. So please hold 1 minute, please. So let's continue that gases are having weak attraction forces. Yes, gases are having weak attraction forces because the gas can move around. The gases are having high energy, so they can overcome the attraction forces. Okay, let's go to the exam questions, which are the following points of comparison. Yes, these are solids, liquid, and gas. And this is our point of comparison. Let's go for the first point of comparison, which is very important, which is the arrangement of particles. So, what do you think about the arrangement of particles in the solid state? Yes, the arrangement of particles, I think they are having fixed shape, they are having fixed volume, they are having low amount and weak energy and low amount of energy, and they are having high attraction force. I think that the arrangement will be a regular arrangement. Would you please hold with me 1 minute? So let's complete. I'm back again. So solids will be having a regular arrangement. Regular arrangement. Particles are regularly arranged. Okay. And for liquids, they can change their shapes. They can change the shape, but they cannot change the volume. I think it is an irregular arrangement. And for gases, for sure, they can change the shape and they can change the volume, so it is also irregular, or we can call it randomly arranged. Let's try to predict the shape of the solid particles and the shape of the liquid particles and the shape of the gaseous particles, the drawing. We can draw the solid particles like this. They are very closely packed, they cannot change their shape, and they are not having high amount of energy, low amount of energy, strong attraction forces, and the shape will be like this, regularly arranged. And for the liquid, I think the shape will be like this. Some particles are touching each other, some particles are not. Please forgive me for this drawing, but as I told you before, I am using an electronic pen, but all particles are of the same size. Yes, this is irregular arrangement, and for the gas, it may be like this. They are having high amount of energy. They can move everywhere. They are having low amount of energy. They are having limited motion. But for solid particles, almost I don't think that they can almost move from their place. But they can make another type of movement we will discuss in the next window. Yes, there are solids, liquid, and gases. Okay, points of comparison. We have almost predicted the shape and the arrangement. Let's try to predict the distance between particles. Distances between particles. Yes, for the solids, they are very closely packed, as we saw in the previous page. And why they are closely packed? If someone asked me why they are closely packed, they do not have energy. Attraction forces is very high. So for liquids, we can say touching. They are almost close, but not very close. For gases, yes, we can say that they are far apart. They are having high amount of energy, weak attraction forces. Let's go to the movement. What do you think about particles which are closely packed, having low amount of energy, cannot move from their place to another place? What is the only type of movement they can do? Yes, you are right. It's only they can vibrate in their fixed positions. So let's go to the liquid. Yes, they are having low amount of energy, not very low like the solid, but moderate amount of energy. They can move, they can change their shapes. Yes, so they will be having a limited motion. They can slide over each other, but they are not freely moving. But to go to the gaseous part and the gaseous matter, you will find that the particles are freely moving, and it can also be said like moving rapidly, moving freely, moving randomly in all directions. Yes, now we have reached the critical point, and we have finally, it had been finally explained why do solid are having fixed shape. Yes, why do solid having fixed shape? Fixed shape because they cannot move from their places. They cannot move from their places, but they can only vibrate in their positions. And why do solids having fixed volume. Yes, they are having fixed volume because particles are very close to each other. They cannot be more closer. You cannot decrease that volume. Okay, so another one, and I can ask another student, why do liquids are having unfixed shape? Yes, Mr. Liquids are having unfixed shape because particles can move from their places. They can move from their places. They are having moderate amount of energy. They can slide over each other. And why do liquids are having fixed volume? Yes, it are having fixed volume because particles are still close to each other. They are almost touching. They are not very close like those of solids, but they are almost touching each other. It means that almost there is no distance between particles. There is a very small distance. They are very hard to be compressed. And it's very hard to make them move more closer, so we can say it as a general, they are having fixed volume. And why gases are having unfixed shapes? Yes, gas is having unfixed shape because particles can move from its place to another place, so shape can be changing. And why they are having unfixed volume? Yes, because there is almost a large distance between particles, allowing these particles to be more closer to each other and consequently decreasing the volume. So we can, if we, the last point of comparison for solid, liquid, and gases is the possibility of compression. Compressibility. Which ones can be compressed? Can I compress a solid? No, solid is impossible to be compressed because if you try to compress a solid, you will damage this solid. Liquids, yes, it is also very hard, very difficult to be compressed. Very difficult to be compressed. For the gases, it is easy to compress. Yes, it's easy to compress. You can hold the balloon and try to compress this balloon. It will be somehow compressed. Yes, gases can be compressed. And we can ask about ourselves the questions. Why are solids difficult to be compressed? Yes, it's a function of the volume also, because there is almost no distance between particles. And liquids also, they are very close and they are touching each other, but very close is commonly said for solids. And gases, there is a large distance between particles, allowing them to be compressed. Compressed means particles get closer to each other. Now let's go back to our notes. Now, yes, this what we explained, that solids are having fixed shape, they're having regular arrangement, liquids are having irregular arrangement, randomly arranged, and gases are having also random arrangement. But can we change the solid to be a liquid for a certain substance and the liquid to be a gas? Yes, we can make these changes. And these changes are having a specific names of their process. The process from which we change solid to a liquid is called melting. And from liquid to a gas, it's named boiling or even evaporation. And we will know further what is the difference between boiling and evaporation. But from liquid to a gas, it's named boiling or evaporation. And from a gas to liquid, yes, it's named condensation. And from liquid to solid, it's named freezing. Some materials can approach a process in which the solid can change directly into a gas, and this is called sublimation, or the gas can change directly into a solid without passing with the liquid state, and this process is also called sublimation. From solid to gas, it's sublimation, and from gas to solid, it is also called sublimation. But let's know, if I need to change a solid to a liquid, shall I make heating or cooling? I can hear someone is telling me cooling. No, you are wrong, because I need to give the solid some energy to be a liquid, as we knew from the previous explaining that liquid is having more energy than solid and gases are having more energy than liquids. So if you need to change a solid into a liquid, you shall make a heating. And if you need to change liquid to a gas, you can also give some heat and increase the temperature, gives energy. But if you need to change a gas to a liquid, you must absorb energy. And how you can absorb energy? By making a cooling process. And from a liquid to solid, you can also absorb the energy with the liquid in order to be decreased, and they can change into solid by making a cooling process. Yes, melting process is a function of heating. Boiling, yes, it involves heating. Gas to liquid, it involves cooling. And liquid to solid, it involves freezing. Yeah, there is a new process named sublimation, in which I told you that some materials and some substances can go directly from the solid to the gaseous states upon heating without passing with the liquid state, and vice versa. Vice versa means the opposite is also right. This is the process which is named sublimation. These substances are like iodine. Iodine is a dark gray solid. From now on, try to bring a small cupbook while you are listening to my videos, because I need to insist, and you need to memorize some colors which are very important and must be studied and memorized during your studying, because you may be asked about in your exam. Solid iodine is a dark gray solid. When heating solid iodine, it directly goes from the solid state to the gaseous state. And this process is named sublimation, and it turns into iodine gas. And iodine gas is a purple in color. These colors are very important. And if you allow the gas to cool again, it will change directly into solid iodine, which is dark gray solid. We are in our Cambridge syllabus. Yes, from solid to gas it is sublimation, and from gas to solid it is also sublimation. But in Edexcel syllabus, you will be finding that from solid to gas it's called sublimation, but from gas to solid it's named deposition. I know I don't need you to be confused now, but if you were asked by anyone, you can answer this answer. Also, carbon dioxide behaves similarly, because solid carbon dioxide can changes directly to gaseous carbon dioxide if it was heated, and also carbon dioxide gas can change directly to solid carbon dioxide if was cooled. Solid carbon dioxide is having a common name named dry ice. Let's continue. And this we talked about, which is the arrangement of particles close together in a regular arrangement, still close together in an irregular arrangement. Particles are far apart. Movement of particles only vibrate in their places, can move around slowly, freely, moving rapidly. So let's now brief what is called kinetic particle theory. This theory is having the following aspects, which were we talked about previously, and some of them can be proved. Let's talk about the first one, which is all matter is made up of very small invisible particles. Yes, all matters are made from very small invisible particles. Why they are invisible? Because the word invisible means that we cannot see them by our naked eyes, because our eyes is seeing in a certain range. You can't see bacteria, you can see coronavirus. If I can see the coronavirus, I will kill him. But why is coronavirus so spreading and making many problems all over the world? Because it can't be seen. It can't be seen. You can't see this coronavirus, and you can simply do not get near it, but you can go away. But what is happening that you can't see it. So our matters are made of very small invisible particles we talked about previously, which are atoms, ions, and molecules. Number two, that the particles move all time. Yes, we saw that particles in solid are moving even if they are vibrating in their places, and particles of liquid are sliding past each other, and particles of gas are moving randomly. And also this was proven that the higher the temperature, the faster they move. Yes, liquid particles are moving faster than solid particles, and gaseous particles are moving faster than liquid particles. Yes, in a gas, there is a relatively large distance between particles. Yes, this is right, because gas can be compressed, gas can fill any volume. The average speed of particles increase with an increase in temperature. Is that right? Yes, when you increase the temperature, the particles will gain more energy and can move faster. We did not say the third one, which is lighter particles move faster than heavier ones. Is that right? Yes, this is right. Lighter particles can move faster than heavier one. If you are having a fat player and a thin player, the fat player will be moving slower than the thin player. And this can be proven in the next lesson, or in this lesson, but in a few pages. Number six, the pressure of a gas is the result of collisions of the particle moving with the walls of the container. What does that mean? If I'm having a balloon, this is a balloon. Yes, it's closed balloon, but my pen. And are the particles of the gas inside the balloon. Is there a pressure inside this balloon? Yes, there is a pressure inside this balloon. How do the pressure come from? Where does the pressure come from? The pressure comes from that these particles are hitting and colliding with the walls of the balloon frequently. What does it mean frequently? Frequently, that means it's related with time. Yes, they hit and they collide the walls of the balloon 5 times per second or 10 times per second. This is called the pressure. The pressure is resulting from the collision. Collisions means hitting of the particles inside a certain container, the particles of the gas, with the walls of this container, walls of a balloon, for instance, or walls of a glass cup, or walls of anything, any container. So, what will happen? What will happen if we increase the temperature for this balloon? Yes, if you increase the temperature for this balloon, if you try to increase or put a balloon in a bowl filled with boiling water, you will find that this balloon will rupture. It will explode. If I inserted the balloon into a bowl filled with boiled water, try to make this experiment at home. Yes, this balloon will rupture. Why? Because by increasing the temperature, the particles will gain more energy. And if the particles gained more energy, they will move faster. And if they moved faster, they will collide more frequently. What does it mean, collide more frequently? It means that if the frequency of collisions was about 5 collisions in 1 second, it will be 10 collisions in 1 second. And when the frequency increase, the pressure on these walls will increase until it cannot attain more pressure and the balloon will rupture. Try to get a balloon almost containing, after you fill it with a gas and you fill the maximum amount of gas in a balloon, try to put it in a bowl filled with not even boiled water in order for safety of the experiment, but with hot water. You can fill البانيو في الحمام or any with hot water, and you put in it the balloon. You will find that the balloon will rupture and the balloon will explode. Why? Because the particles will gain more energy, moving faster, and they will hit the walls and collide with the walls of the container more frequently. And if they're collided with the walls of the container more frequently, this will increase the pressure and the balloon will rupture. This experiment proves for us that gaseous particles are moving freely. This also proves for us that when we increase the temperature, particles move faster. Yes, we are proving many aspects from the kinetic particle theory. Let's go down and see how do state changes. How can I change a solid to a liquid? Someone tells me, yes, Mr. By the process melting. I need to know what exactly happens during melting. Yes, when a solid is heated, the particles get more energy and they vibrate more until they are having a maximum vibration. They cannot vibrate more than that at this state. At this point is called the melting point. Now, the forces between them starts to break down. And when these forces starts to break down, they change into the liquid state. You can see from here, this figure to this one, that the volume was increased. Yes, because the distance between particles was increased because they are vibrating more in their positions. But you must know that the size of particles was still the same. Size of particles was not changed, but only the distance changed and they were converted into a liquid. The point at which the forces are being broken and the state changed from solid to a liquid is named the melting point. And here we can go with the boiling. It's the same idea. When the liquid is heated, the particles get more energy. We cannot say here vibrate faster, we can say move faster because already in the liquid they were moving around. Okay, my students, I'm sorry for that interruption. It was only an internet disconnection, but we can complete again and we can say again what happens during melting. At a point which is named the melting point, it is the temperature at which the solid starts to melt and changes into liquid. And at this point, the forces between the particles which are holding them together are overcome and they start to go into another state with a lower attraction force, which are named liquid. And for the boiling, it's the same idea. When the liquid is heated, yes, the particles gain more energy and move faster. We cannot say vibrate faster because the particles are already moving and sliding past each other. At the boiling point, the particles get enough energy. Yes, they can overcome the forces of the liquid state holding them together and they can break from their liquid form and form a gas. Yes, the volume has increased, but the particle size did not change. Volume increased because the distance between particles was increased. And at the boiling point, forces are overcome and can change into gas form, gaseous state. Yes, what is the definition of the boiling point? Boiling point is the temperature at which the liquid boils, which means changes into gas. Okay, so the boiling point is the temperature at which the attraction forces between liquid particles is overcome, and finally the liquid can changes into another state with a lower attraction force with a higher energy and forms a gas. The last thing we can say in this video, in order not to be a long one, you can only see this video and reach this point, which we explain the states of matter and how we can change a state to another state, and we can complete this lesson in the next video. But I need you to know that melting and boiling point are used to identify a substance, because each substance God created is having a definite melting and boiling points. Like, for instance, pure water is having a boiling point of 100 and a melting point of 0 degrees Celsius. Yes, if another substance, it will be having another melting point, another boiling point. Each pure substance is having a definite and sharp melting and boiling points. But what about if the substance was impure? If the substance was impure, that means that it will not be having a fixed melting point. What does it mean, fixed melting point? That means if you have a piece of ice and this piece is being melted into water, and if you are having a thermometer here which is measuring the temperature, you know, all over the melting process the temperature will be only 0 degrees Celsius. It will not be increasing or decreasing, it will be fixed at 0 because the melting process is occurring. But if the ice was impure, you will find that the reading of the thermometer is changing. The reading is changing, not a fixed reading. So it will not be a definite melting point. It will be a range of, of temperature, not a definite one, not 0. For instance, it will starts from -2 degrees Celsius and ends, for instance, at 0 degrees Celsius. You will find that the temperature is changing over the melting process. Yes, why is the temperature changing? Because there is impurities. There are another substance. So some substance can melt at 0, some others can melt at -1, -2. So it's a mixture of substance having different melting points. So you will be having a range of points, and also the melting point will be decreased than that of the original substance. Yes, if the original substance melting point was, for instance, 0 degrees Celsius, this is for the pure substance. But for the impure, you will find the melting point decreasing than the original one, for instance, -2 degrees Celsius. This is for the melting point. And for the boiling point, if the original substance and the pure one, original pure substance, if it was 100 degrees Celsius, you will find the impure one about 102 degrees Celsius. Any number above 100, but near to 100, 102, 103, anything. All I want you to know before ending that video, that if the substance was impure, melting point will decrease. If the substance was impure, the boiling point will increase. I would like to thank you very much, dear students. Um, you will find this video on my channel on my YouTube. Again, my name is Bishoy Salama, and my number is 002 012 018 58910. You can answer me about anything in the comment section, and you can also send me WhatsApp to ask about anything in chemistry or any question. You can just take a screenshot and send me on WhatsApp, and I will answer you freely, totally free. And if you need further lessons, you can just text me on WhatsApp. Thank you very much, my dear students, and see you soon, inshallah.